you're about to make a choice. Small one. In a moment, you'll decide to move your hand whenever you feel like it. No rule, no reason. Just a free, spontaneous flick, chosen by you. Except a machine watching your brain has a problem for you, because in experiments like this, a specific pattern of brain activity begins to build before you feel any urge to move at all. Not milliseconds before. In some studies, seconds before. A rising electrical signal, quietly climbing toward action, while you sit there believing you haven't decided yet. And then you feel the urge. And you move. And you are absolutely certain it was you who chose. So here is the question that has haunted neuroscience for 40 years. If your brain starts acting before you're aware of deciding, who exactly is making the decision? Is the feeling of choosing real? Or is it a story your mind tells you, a fraction of a second too late, about something your brain already set in motion? To the mystery, the hardest question in science, free will sits on the exact border where science meets philosophy, and almost nothing lives there comfortably. For most of history it was a question for theologians and philosophers. Do we author our own actions? Or are we links in an unbroken chain of cause and effect, stretching back to before we were born? What changed is that, for the first time, the question moved into the laboratory. We built tools that could watch the brain in the act of deciding. EEG caps reading electrical storms across the scalp. fMRI scanners tracking blood flow through the machinery of thought. Suddenly, when does a decision happen, was something you could try to measure with a stopwatch. And what the measurement seemed to show was deeply unsettling. That the brain commits to an action before the conscious mind knows about it. That the self who feels in charge might be more like a spokesperson than a president, announcing decisions it didn't actually make. If that were true, it wouldn't just be a curiosity. It would touch everything: responsibility, blame, praise. The entire idea that you are the author of your life. Which is exactly why the science here has to be handled with unusual care. Because the temptation to overstate it is enormous. 3. What do we even mean by free will? This is where most debates go wrong in the first sentence. People argue furiously about free will while meaning completely different things by it. There are roughly 3 camps, and the science lands very differently depending on which one you're in. The first is determinism, the idea that every event, including every thought and choice, is the inevitable result of prior causes obeying the laws of physics. On this view, if you could know the exact state of the universe, every particle, every neuron, you could in principle predict every decision you'll ever make. The future is already fixed. You just haven't lived it yet. The second is libertarian free will, no relation to the politics. This is the intuitive version most people feel they have, that in any moment, you genuinely could have done otherwise, that your choices are not fully fixed by the past. For this to be true, there has to be a real crack in the chain of cause and effect. And the third, the one most professional philosophers actually hold, is compatibilism, the view that free will and determinism can both be true at once, because free doesn't have to mean uncaused. It means something more practical, that your action flowed from your own reasons, your own desires, without external coercion. On this view, a choice can be fully caused by your brain and still be freely yours, precisely because your brain is you. Hold on to that distinction, because it's the key to the whole story. When a headline says scientists proved free will is an illusion, the real question is always, which free will? Because an experiment can wound one of these ideas while leaving another completely untouched. For the experiment that nearly killed free will, Libet's clock. In 1983, a physiologist named Benjamin Libet ran a study so simple it's almost strange it became legendary. He wired volunteers to an EEG machine and asked them to do one thing: flick their wrist whenever they felt the urge, and note the exact position of a dot on a special fast clock at the moment they first became aware of the intention to move. So he had 3 timestamps. When the brain's electrical activity started ramping up, when the person consciously felt the decision, and when the muscle actually moved. The order should have been obvious: decide, then brain activity, then movement. That's what it feels like. That is not what he found. The brain's rising signal, a wave called the readiness-potential, began about 1/3 of a second, sometimes more, before people reported being aware of deciding anything. The brain, it seemed, was preparing to act before the conscious mind had made the call. It landed like a bomb. Here, apparently, was physical proof that the decision happens first, in the dark, and consciousness only finds out afterward. The scanner that saw seconds ahead. Then it got more dramatic. In 2008, a team led by John Dylan Haynes, with Chun Shong Soon, put people in an fMRI scanner and let them freely choose to press a left or right button. By reading patterns in the prefrontal and parietal cortex, they could predict which button a person would press up to 7, even 10 seconds before the person felt they'd decided. Seconds. An eternity in the brain. It seemed to seal the case. But notice one number that rarely makes the headlines. The prediction was only about 60% accurate. Better than a coin flip reel. Not nothing. But nowhere near certainty. Which quietly tells you something important. Whatever that early brain activity was, it did not fully determine the final choice. Something else was still in play. The rebuttal that changed everything. For nearly 30 years, the Libet result stood as the great scientific challenge to free will. And then, in 2012, a neuroscientist named Aaron Scherger asked a question that cracked it open. What if the readiness potential isn't a decision at all? Scherger and his colleagues proposed something subtle. The brain is never silent. It hums with constant, random fluctuation noise, rising and falling. 5. The biology of a choice. Step back from the clock and ask a bigger question. When you make a decision, a real one, not a random flick, what is actually doing the deciding? The honest answer from biology is an enormous amount of machinery you never see and didn't choose. Start with genes. Your temperament, your impulsivity, how strongly you feel reward, how much risk thrills or frightens you. All of these are shaped, in part, by DNA you inherited before you had any say in anything. Add neurochemistry. The moment-to moment, tilt of your decisions rides on. Chemicals like dopamine and serotonin leveluenced by your genes, your sleep, your last meal, whether you're stressed, even the bacteria in your gut. A hungry judge and a well-fed judge are, measurably, not quite the same decision-maker. Then there's priming, the unsettling finding that subtle cues in your environment nudge your choices without your knowledge. The words you just read, the temperature of the room, a face you glimpsed. These can tilt behaviour in ways people confidently deny afterward. And here is the part that should genuinely give you pause. When researchers ask people why they made a choice, people readily produce reasons, confident, coherent reasons. But in experiments where the real cause was hidden, those reasons are often invented after the fact. The mind is a masterful storyteller, and one of its favourite stories is that it was in charge all along. None of this proves free will is an illusion, but it reframes the question hard. Whatever you are not a clean, separate chooser floating above your biology. You are the biology, genes, chemistry, history, and noise, all braided together into something that experiences itself as making up its mind. 6. Can we override ourselves? If unconscious processes get the ball rolling, maybe freedom isn't about starting actions at all. Maybe it's about stopping them. This is the idea behind Libet's free won't, and it points to one of the brain's most important tricks, inhibition. The prefrontal cortex, the region right behind your forehead, the last part of the human brain to fully mature, is heavily involved in impulse control. In lab tasks where people must cancel an action at the last instant, you can watch this braking system fire. The urge to grab the second slice, snap back the angry reply, reach for the thing you're trying to quit. The impulse may arrive unbidden, but there's a gap, however brief, between impulse and action, and in that gap, something can intervene. Whether you want to call that free will depends entirely on which definition you picked earlier. To a hard determinist, even the veto is just more caused brain. Activity, the brake is as determined as the accelerator. To a compatibilist, this is exactly what meaningful freedom looks like. A system complex enough to model its own impulses and sometimes overrule them, for its own reasons. What the neuroscience shows cleanly is this.